Okay, so today we are looking at distance times time equals distance. So let's think about what that even means. Rate. What is rate? When we're talking like everyday life, it's your... I heard someone say speed, I think. Yeah, it's like a speed, right? So imagine you're driving in the car, you're going 30 miles per hour. Times time. If you drive at 30 miles per hour for 2 hours, can't you tell me the distance you've gone? 60 miles, right? 30 miles per hour for 2 hours. Well, that's 60, right? Because I went 30 miles the first hour, 30 miles the second hour, 60 miles altogether. So that's the formula that we're using. It's very simple, only those pieces. Rate times time always equals distance. Okay, so if you went 70 miles per hour for 3 hours, what would your distance be? Tell me, Maddie V. 70 miles per hour for 3 hours. 210 miles, right? 70 miles per hour, 3 hours, 70 times 3, 210. Okay, that makes sense. So we're going to be using this equation, all right? Now, there's some different scenarios that can happen. So that's sort of outlined right here. You can have two things traveling in opposite directions. So this might be like two trains leave the same station, but one's going east and one's going west, all right? You could have maybe at the end of the day, all of us are going to leave Tantascwa. Someone might go north, someone might go south. So that's anything that's starting in the same spot and just traveling in opposite directions, all right? So if we have that, we're going to be adding the distances and setting equal to a given distance. We'll go through examples of each, don't worry, all right? Same direction. So sometimes what happens is these are two things that started at the same point but at different times. So this might be you left for school, but then your mom was like, oh no, he forgot his lunch. So then she like drives fast to catch up with your bus, and then catches up with your bus and says, oh, here's your lunch. You both left your house.
I'd be embarrassed.
I know. But you could imagine this scenario, right? You get on the bus leaves, it's going along its route, right? And then your mom's like, oh, Susie forgot her lunch. I gotta get her lunch. So your mom just drives quickly so she can catch up with the bus, and then you've both gone the same distance, haven't you? She just did it quicker. So that's another scenario that has. And then we also have a third scenario that's a round trip. So you went to work and you came back. You went to the gym, you came back. You went to the restroom, you came back. Round trip. It's one person going there and coming back again. So those are our three basic scenarios with these distance word problems, okay? So you just want to figure out which one you're in and then set it up accordingly, okay? So let's take a look at this first one. We're going to set up a chart for each of these. So you'll notice on the front side here, I already have the chart sort of laid out for you until you get used to it. So let's read it together. It says, Olivia and Jordan leave Sturbridge in opposite directions. Olivia drives at 55 miles per hour. Jordan drives at 65 miles per hour. After how many hours will Olivia and Jordan be 720 miles apart? Can you imagine this? I want you to imagine I have Olivia and Jordan. They're both in Sturbridge. They're going to leave Sturbridge, and they're going to travel in opposite directions. However, Olivia's going 55, Jordan's going 65. So when they leave, one person's going faster than the other. Do you see that? They're traveling in opposite directions, but one person's going faster than the other. At some point, they will be 720 miles apart, won't they? Yeah, eventually, if they keep going, at some point they will be 720 miles apart from each other. I want to figure out how long it's going to take for that to happen. It sounds way more complicated than it is. Especially when you have this chart, it's really not that bad. So what you're going to do, your chart is the same every time.
Do we have to make a chart?
I sure would. If you don't, it's going to make your life way harder. Remember, we work smarter, not harder. Rate times time equals distance. Olivia. There's two people, Olivia and Jordan. Do you know Olivia's rate? Remember, rate is just another word for speed. Do you know Olivia's speed? 55. It said it right in there. Olivia drives at 55. I'm going to put in a 55 for Olivia. That was easy. Jordan. Do you know Jordan's rate? 65. Time. Do we know how much time they've spent driving? No. So I need to go back and say let t equal time. And this time we're using t instead of x. You could use x if you wanted. Who cares? They have it set up to use t. So, do I know how long Olivia has been driving for? No, I'm going to call it t. Do you know how long Jordan's been driving for? But you do know something. You do know that they've both been traveling for the same amount of time, haven't you? Haven't they? They both left Sturbridge, and then they just keep going, and keep going. And then at some point, I'm going to stop them and say, okay, you're at 720 miles apart from each other. So T goes in for Jordan's time as well. And I want to specify, T always means time that has passed. It's not time of day. So if they say that something happens at 2 o'clock, that doesn't mean you put a 2 in here, right? It's how many hours has the person's been driving for, or the plane has been flying for, or the train has been traveling for. It's never time of day. All right, guys, that was not that hard so far, right? I just put in some T's and I knew the rates here. Once you have the rate and the time columns filled out, you automatically know what goes in these boxes. How? Because rate times time gets you distance. So I just multiply these two things together. That's it. What's 55 times t? 55t. What's 65 times t? 65t. Here's where it now matters which of these I have. Do I have two people traveling in opposite directions? Yes, I do. So it tells me right here, add distances and set equal to a given distance. So the distance that Olivia went is right here. She went 55t. So actually, I'm going to write this in words. So hold on, because this might help some of you. I'm going to take the distance Olivia went. I'm going to add that to the distance Jordan went. And what's it going to get me all together? 720. All I have to do is change the words into math. What's the distance Olivia went? According to my chart, it's 55t. What's the distance Jordan went? 65t. And together they went 720 miles. All I have to do is solve for t. And then I'm done. This really isn't so bad. So what is 55t plus 65t? 120t equals 720. Divide both sides by 120. 720 divided by 120 gets me 6. So what's the answer to my question? After 6 hours, Olivia and Jordan are going to be 720 miles apart. Does that make sense? So after 6 hours, they are 720 miles apart. Oh, sorry. There it is. Okay.